Hello everyone. Complex numbers, real imaginary parts, polar and rectangular forms or coordinates. Rectangular is also known as Cartesian. I'll show you how to set up the calculator when we're looking at complex numbers with real and imaginary parts, and then how to switch between the two on the calculator. So if we hit mode, we will need to be in complex mode, so we hit 2 for that and we should see complex come up there. And then if we go shift and then setup, which is also the mode button, we want 3 for degrees. We can also do an additional setting which will decide how the calculator displays its results. So if we go shift setup again and we go down onto the next page, select 3 for complex, and then it shows you which way you want your results. Do you want them in rectangular or polar form? So if you press 1 for rectangular on this one, and if we look at problem 1 here, so if we have 4 plus 6 shift eng tab, which has the little I above it. So in electrical engineering we use J as the imaginary term. The rest of mathematics use I. We use J because I means current, and that's all it is. So I'm getting, my result is exactly the same as what I've just put in. Now I can press shift and then 2, which has a complex above it, and I can select 3 to show it in polar form. Answer in polar form is 2 the square root of 13 angle 56. I can work that out, or if I press the S to D button there, it will show me that the answer is 7.21 angle 56.31. That's how I've switched it from rectangular to polar. Going the other way, so if I take this problem here, so we've got 9 and then the angle is shift and it's like a minus in the bracket, but it's got the angle symbol above it. And then if I choose minus 0.64 and then hit equals, it's given me this big long number, and I can scroll across, or I can hit the S to D button again and that will display it all. So I'm looking for an answer of 9 minus J 0.1. That's how to switch from polar to rectangular and back again. So if I want to change this answer to be in polar, 2 3 equals the polar form, and then back shift 2 4 equals, and I've got my answer again there. So a little bit about what the complex number is showing us. Complex number is made up of 2 parts, a real part and an imaginary part. If we look at that on this graph here, our rectangular is our A and our B, which takes us to this coordinate. So our Z equals A plus JB, or we can get to there by using R, which is a vector, and a vector is a line that has a magnitude and a direction, normally has a little arrow on the end, and the angle of that. So it's 2 ways of getting to the same coordinate. So on here, Z is our complex number, A is our real component, like a resistor, and B is our imaginary component, like a reactance that you would get from a capacitor or an inductor. R is our vector length, and theta is our angle. So an RC circuit impedance would be Z equals R plus JXC, where XC is our capacitive reactance, R is our resistance, which is a real component, and this is generally Z impedance replaces R in AC circuits where they have reactance. So our Ohm's law, V equals IR, would become V equals IZ. And this is because the reactive components cause the current to lead or lag the voltage.